Hi, good morning. This is BK Behera from Behera Textile Tutorials. Today we will learn about the Cumber machine. You can see this is Cumber machine with the 10 working heads. Cumber machine principle. The Cumber machine is to remove short fiber and impurities from sheet of fibers from the lap objects of Cumber machine. To remove short fiber so as to enable spinner to produce finer yarn with good strength, good quality. You know, we need the comber to take out the short fibers from the fiber to spin the higher counts and with the good strength and good quality. Second, to improve parallelization of fibers so that yarn becomes even and lustrous. To remove impurities and nets to get better quality of yarn with the minimum IPA. To remove leading hooks to get the actual length of fiber in the yarn. I have demonstrated you about the leading hooks and trailing hooks in before video. So in this combo, it removes the leading hooks. To prepare uniform sliver of required weight per unit length for further process. So combo is main objective is to remove short fiber impurities, to paralyze, to remove leading hooks, and to produce a sliver with good quality. You can see this. This is the diagram of the Cumber machine. Cumber principle of working. You can see that figure and you can understand this sail roller 2, feed roller 3 and set of nippers 4 and 5 moves forward to pitch the combed fibers to the detaching roller 8. The top nipper 5 remain upper position to release the combed fiber. The top comb 7 remain penetrated in the sheet of fibers. When it is delivering the material, the top comb is penetrated in the sheet of fiber to ensure the fibers paralyzed and the trailing hooks straightened. Mainly, keep in mind the circular comb removes the leading hooks, and the main object of the comber is to remove leading hooks, remove short fiber and impurities. But at last moment, the top comb also straighten the fiber and remove the trailing hooks. After the fiber taken by detaching roller, the unit comes backward and the feed roller rotates to feed the lap forward. After coming back, the top nipper 5 comes to close with the bottom nipper to hold the lap seat. Then the circular comb rotates to comb the lap seat. After complete of combing process, again feeding unit goes forward to pitch the combed fibers to the detaching roller 8. The web of fibers goes through the feed table 10 to the drafting rollers 11, then calendar roller 12 and the delivery roller 13. This process repeats again and again. You can see this is the combing operation. See, this unicomb comb the material when then it is coming forward and pitch the material. Then it is going forward. This is a calculation. I have taken six examples, means three types of machine with the 8 heads, with the 10 heads, and with the 11 heads. So this 8 heads I have taken feed per nib 4.7 and 5.2. With the 10 heads I have taken feed per nib 4.7 and 5.2. and with 21 heads I have taken feed per nib 4.7 and 5.2. So we can see first 2 points is with 8 heads, and the middle 2 column is 10 head, and the last 2 column is 21 head. And here the required draft at drafting on the coiler, it is lower in 8 head and little more in 10 head, and very high in 21 heads. As you know, if we increase the draft, the quality will be inferior, not good. So, as you see, the production is high. For the 21 head, production is high. But so much draft with 23, 24 draft, how it is possible to take a good quality? So you can see the with 10 heads, it is the draft is tolerable, means 11.2 for 10.16, it is tolerable. With 8 heads it is 8.99, 8.13, okay. But with 10 heads also the draft is tolerable and production is high, better than 8 heads. And so you can see the suitable machine is with 10 heads. And this is the mainly calculation I have given. Draft calculated 0.245 into lap weight into feed per nib into 100 minus lap tension divided by 100 into 100 minus Noel divided by 100 divided by sliver kilotex. Then required draft at drafting on the coiler. This is delivery sliver hank divided by sliver hank on table. I have given on this table, comparative table, and into number of heads into table draft. Then production in kgs per day equal to nibs per minute into feed per nib into 100 minus Noel by 100 into number of heads into lap weight into efficiency by 100 into 100 minus lap tension divided by 1000000. This is for conversion feed per nib means mm to meter and gram to kg. This is the conversion factor 1000000. And as per the draft calculation, we see in the table the required draft for 8 heads and 10 heads are in tolerable limit, but the draft for 21 heads is very high. As we know, if you apply more draft, then quality will be inferior. So the 21 heads is not suitable for the process. Cumber with 10 heads is suitable because it gives more production and a draft in tolerable limit. Thank you.